and I'm going to be presenting scaling batch jobs. And for this talk, I'm going to be heavily talking about Spring Batch. Okay? Before we start, how many of you already use Spring Batch or know Spring Batch? Okay, good number, more than half. For the others that are not using Spring Batch, what are you using to do, I don't know, any weekly routine that you need to do, or using Batch, using something else? Bash, scripts, cron jobs? What do you use? Got it. And what do you do when it fails? How you get notified? Got it. Okay. Gotcha. All right. Right. So you're going to see that when I built this talk, obviously that many of the talks were about streaming and a bunch of other fancy technologies, while every company does have a bunch of batch jobs. Right? Everyone has a report that needs to run, I don't know, once a week, once a day, any different things that need to be done. And I thought that Spring Batch is a good use case for that. And once the data increases, it can also be useful. All right. All right. So quickly, as I said, my name is Rodrigo Graciano. I'm a Java champion. I'm part of the GCP executive committee for BNY Mellon, where I work. I've been programming for a long time, and also one of the leaders of the Java group from New York. So if any of you is from New York, there are monthly meetings, events, hands-on workshops, completely free, right? All right, so I'm going to do a quickly intro on Spring Batch. So Spring Batch is a lightweight framework, as you can see. It's very good for a finite amount of data, right? So, sorry. If you have like a streaming or something, Spring Batch can be useful, but I do not recommend. I don't think that's the best use case for Spring Batch. Also, Spring Batch is not a scheduler. So if you need a scheduler, there are other options in the market. So that's not for Spring Batch. And it's a very simple architecture. As you can see, the basic architecture of Spring Batch, we have a launcher, which will launch a job. And a job can have one to multiple steps, right? So we're going to see that there are different ways. Suppose you have a job where you need to read a data from a file, write to the database, and then you need to get this database, join with another database, and write a report. So those are all the steps that we would do with Spring Batch. And there is a job repository where we keep the status of the application. So you're going to see how many items were written, how many writes were read, if something failed, or everything is going to be on the job repository. All right. So here's easy. You can read. All right. We're going to see how it's easy to define a job within Spring Batch. So you can see we have here a job. We're defining our job. We're putting a name. Our name is job. And we're passing a job repository. And we're saying start the simple step, right? And the step, use a step builder. So on version 5 of Spring Batch, that's changed. It was before it was a job builder factory and a step builder factory, until version 4. On version 5, it changed to a job builder and a step builder. It's changed a little bit the API. So here we're going to say, like, we have a field set. Our input is a field set. Our output is a field set. and we're going to do in chunks of 100 items. And we have a reader and a writer, right? So, short. Let me see if I can zoom in. Let me try to do one thing here. Let me see. That's look better? All right. So we have here the reader, and this reader is a flat file. It's going to read from a file. We're putting here, the file name is input file. It's a delimited, so CSV. And we're just going to pass through. We're not going to do anything, not going to process that, not any transformation. So we just map that to this. It's going to map to a field set, which is a basic Spring Batch object. And the writer as well, you see, very simple. So this use case is just read the file and write a file. It doesn't do anything, any transformation, but just to show the different components. So you see with like 20 lines of code here, you'll be able to create a job that reads a file and writes to a file. So it's really simple how to do it. All right, I mentioned before the job repository. So everything you do in Spring Batch is going to be on the job repository. So that's where we're going to keep status of your application. You're going to, and also useful when your job fails and need to restart. That's all the where all the information is going to be. So Spring Batch, we use the job repository to be able to restart the job. So Spring Batch does need those 1, 2, 3, 4, 5, 6 tables to work. If you use Spring Batch, you know that all the scripts you create, those tables come with the Spring Batch. So for different databases you can work with. So it's pretty easy to have started. And that also changes from version 4 to 5. So again, this presentation is using the last version, the version 5 with Java 17. All right, for those using Spring Batch, what do you use, XML or notation? Notation. Which version are you using? Spring Batch 4? 5? 3 something. So does the tree have the enable batch processing annotation? Yeah, all right. So that's something that was very complicated when I migrated this presentation to Spring Batch. So the annotation enable batch processing. So you're creating a Spring Batch application using Spring Boot, right? And you have defined a data source. Spring Batch will use this data source, and we'll create also the transaction manager and a bunch of beans that it needs to run. So job repository, launcher, all those that are on the screen. Perfectly. Starting on version 5, if you add this annotation enable batch processing, it doesn't do any of that. Okay? So that took me like 2 hours to resolve. And the way to do it is you just don't add the annotation. So your application should not have this annotation, and then it will create all those beans for you. So I thought it was a little bit confusing when we migrated for the version 4 to 5. But I learned the lesson, and I don't want you to spend 2 hours like I did on that. Okay. Okay. So 2 types of steps are available. Okay. So tasklets and chunky-oriented, because the job that we saw, the first one, there was a reader and a writer. So all of that is part of the chunk-oriented step. But there are use cases where you don't want to read and write the data. You need to, I don't know, unzip files, download files from S3, a couple of different tasks that you need to do. And for that, there is the tasklet step, where you want to do a one-time perform a one-time job. So in this case, we're using a tasklet that just clean the directory, user temp files, and that's it. It doesn't do much. So any time that you need to perform a one-time thing, tasklet is your person. I know that some people did different things using like an empty reader and an empty writer and did all this logic on the processor. So don't do that. There's easier ways and that look better than that. Readers. So Spring Batch provide off the box a bunch of things that's for you. So you don't need to be reinventing the wheel. So instead of having to create all your logic, how to read a file, how to read from the database, Spring Batch provides all of that for you. So to get data from database, so different types of databases, flat files can be delimited, fixed length, XML, JSON. Also, there is this concept of multi-file. So suppose you receive 100 files a day that they have the same columns, right? Same format. So by default, you would have to do one by one in this set. So you're going to have a bunch of steps. So the multi-file, you can say, oh, get all these files from this directory, and that's going to be a one-time thing. I wanted to process all of them at once. So that's going to be part of one step. So that is very useful for this kind of scenarios where you have a lot of files with the same format. Okay? You don't need to create multiple steps for that. So it has the support for JMS and Kafka, AMQP and other things, but I still think that's strange to work with Spring Batch using that. So, for example, JMS, it would be consuming messages until no messages are more available. But that's kind of tricky, right? How would you know that really finished and you're not waiting for more messages? I think it can be time-based as well. You can say, oh, read the message, consume message for 1 minute. So I think that's not the best use case for Spring Batch. Hi, writers, the same way that have all those readers for database and files, for the writers, it's not different. Okay, so same kind of things we can do, same database files, but you can do with the writers. All right. And we also have this concept of the processors. So it should be close to the mic. So we saw that we have the readers and the writers, but what about the business logic? What about transformation? Okay? So all of that can be done on the processor. Okay? So this is part of the chunky-oriented step, and processors, they are optional. Readers and writers are mandatory to have in your step. Processors are optional. So in this case, this processor is not doing anything, so, but the API says, you have a processor, you're going to say what type of data you are receiving. So in this case here, a field set, and also what type of data you are returning. So in this case, a field set. But it can be different things. It can be a DTO that you received, and you map into a different DTO. It can be two different objects completely. And you're going to add your business logic here, so you can do different kind of things. You can filter, you can add validations. And the way it works is if you return, so you receive here a field set, you return this object, that's fine. If you return no, Spring Batch will understand that this item should be filtered out and not be part of your batch. Okay? So that's the use case for processors. And listeners, so Spring Batch does provide a bunch of different listeners. So if you need to do something before your applications, before your job starts, and after your job starts, so you have the listeners for that. So suppose I need every time my job runs, I need to delete the data from my staging table. Okay? You can use a before job annotation to do that. So you have different things. We have for before, after job, we have for steps, for listeners, read, writers, processors, for the chunk, and skip, which is skip is a notation that when you have an error during your processor, you can tell Spring Batch to ignore this record and keep processing. Of course, otherwise, Spring Batch by default would just roll back the transaction. Okay. Okay. There are 5 different ways to scale batch applications. So the first one is a parallel step. So as we saw before, we can have 1 to multiple steps in one job. Okay? And by default, all those jobs are going to run sequentially. And if you can parallelize this processing, you're getting a performance. So parallel steps is one way that we can increase performance. Second one, async processor and writer. And those two, they need to be together. You cannot have an async processor without having an async writer, and the other way around. They must work together, and we're going to see why. Multithreading, remote chunking, and remote partitioning. And most of those use cases then can be combined as well. Okay? All right. So going to parallel steps, return. So by default, as I said, the Spring Batch will process all steps sequentially. So if you have 10 steps, it's going to run step 1, step 2, step 3, and so on, so on, so on. Okay? There's other ways that you can run your steps. So you can add conditions. Suppose you have you start with the step 1, and based on some condition, I don't know, today is a holiday, you run to step 2, otherwise you run to step 3. So you have this flexibility to do with Spring Batch as well. So in this case, it's going to run or 2 or 3, not them together. And the split flow, which is the parallel flow. Okay? So here, we start, and you can say, run step 1 and run step 2 together, and run in a separate thread, trigger step 3. And when they both complete, run step 4. So here we're saying that 1 and 2 can run in parallel with 3, but to run 4, we depend on both of them. Okay? So that's another thing out of the box with Spring Batch. Second use cases, async processor and writer. So what that's going to do is that the processor is going to be executed on a separate thread. So suppose you have something that's going to be heavy on the processing, and it's going to be holding your thread, or you're going to be waiting for some information or something. In this case, you can use this async processor. You're going to trigger your processor, whatever task you need to do, and you're going to pass a future to the writer. So your thread's not going to be there waiting for the processor to finish. Okay? So it's going to release the thread, and when it completes, the writer is going to receive this result. And we're going to see later here some use cases on how useful that can be. And for that, instead of using a regular item processor and item writer, we use an async item processor, async item writer, also Spring Batch components, and they're going to be just a wrapper around your regular processor. So here, I'm going to just say I'll use this processor here on line 4. On line 12, I say use this writer here, rental writer, rental processor. And that's pretty much all you have to do to have async processors and writers. Okay? Clear? No? Yes? Questions? Sure? If I have to write? Yes. Yes. We're going to see, for example, using all those techniques. All right. Multithreading. Very easy to achieve. Use a task executor. So for each chunk of data, it will read, process, and write on a separate thread. Okay? So we have, before the first job that we saw, we have the step pretty much like this from line 9 to 13. And the only difference is here we are creating a thread pool executor. I'm saying that you can use 4 threads, and I added here on line 12 a task executor and passed this executor. That's the only difference from the processor, from the step that we saw in the beginning. Okay? That's it. And for that, we're saying, okay, you can run in 4 different threads. Instead of running a single one, you can run in 4 different threads. Okay, so super simple. You can work with different executors here. All right. So the next two, remote partition and remote chunking, as the name says, that's gonna run on different VMs. So we're gonna be working with multiple machines. So we have something that's very heavy or a lot of data, and you want to split that's the way to go. So the remote partition and chunking, they are somehow similar. On the partition, the data is local to the workers. So the workers, they do have access to the job repository. So you don't need a middleware to have the communication between the manager and the workers. And suppose this partition is going to be, you can partition that, depends, I don't know, suppose you were receiving a bunch of data from clients, you can partition that by, I don't know, name of the client, company, you select how you want to split. Process from clients that start from A to F in one thread and in one VM, and you can choose how you're going to partition this data. And for remote chunking, you do need a middleware. Okay, there can be different things, but must be a durable middleware because the workers, they won't have access to the job repository. Okay, so they cannot get the data from the job repository. So in this case, what happens is that the manager is going to read the data and send over the wire to the workers. Okay, so you can see that's going to be way more I/O intensive. But depending on your use case, right? If your bottleneck is on your processor and you can afford to read the data and your bottleneck is on the processor, so you're going to read the data, send off the wire to your workers, and they're going to process this data for you. So here we're creating, so there are two different components that you need to create. A manager and one to multiple workers. I suppose we're going to have multiple ones. But it's different. So we're going to have a step. On the manager is going to have a step. So it's not different. The name of step, how much data you're going to read by time. So here, chunk of 100 records. And I'm saying that my reader is going to be this library reader. And I have here I'm using an MQ. So I have two durable queues, a request and response. So I'm saying that I'm going to send the data. The manager is going to send the data on the request queue, and the manager is going to receive the data on the response queue. Okay? The worker on the other side, they're going to have exactly the opposite, right? They're going to input the data, they're going to receive the data on the request queue, they're going to receive the data, and they're going to send the data back on the response queue. As you can see here, the worker does not read data. The worker does not have a read data. It has a processor and a writer where it's going to send the data back, and the manager has only the reader. Okay. See how we are in time. Oh, we're good. Not going to go over that. When you get this presentation, have everything that you need to do, how to run the jobs. Different example? Sure. Yeah, so he's asking how does it work if they need to share the jar file, how the data is propagates, if you need to serialize the data between the manager and the worker. I'm gonna show the example here. We're gonna see how that goes. For this example here, I have one application, one jar, with different profiles. Okay, So it's different Spring Batch profiles. But you can have different jars as well. That's not a problem. Because the only thing that they need to share is that in one side you need to have the logic from the manager, right? And how they're going to communicate. So you can have two different jars for that, and that would be perfect fine, or the same. In this case here, I have the same jar file running with different profiles. Okay. Okay, let me get out of here. No, I'm not in presentation mode anymore. Cool. All right, let's see some code. Source is good? All right, so this is just a Spring Batch annotation. Use, as I said, Java 17, Spring Batch 5.01. I think that's the last version for 5.02. Nothing special here, as you can see. I'm just putting something on the job parameters, just saying get data from this file. So this file is here on my resource folder, is a CSV file that has 10,000 records. Okay, nothing special here. Okay, right. That's because of the remote chunking and partition. That's why you need it. Because you use Spring integration to do that. To run without the other examples, you don't need the annotation. Yeah, and as you can see as well, the annotation, the enable batch processing is not here anymore, right? Okay, so this job is very simple. It's pretty similar to what we saw, the first one we saw. So we have a simple job. We're having one step. That's it. This step is going to read the data in chunks of 500. Okay, and this processor is not running now. So for this, I'm using a record field set mapper. I think that was added on Spring on batch 4 or something. So it supports two records. So I have here a record, has ID, title, ISBN, and user. Okay. So this will automatically map my object to a record, using this record field set mapper. So we're reading from the file, and then I'm going to write to the database. Okay? Let me see if I have it running. Yeah, database is running. And if I go here, we're going to insert on this rental table, and right now there is nothing on this table. Okay, so I'm going to run this object, going to run this simple profile. Again, 10,000 records, read from file, write to the database. I should have asked before how long you think it's going to take to run. 10 seconds, it did that. Okay? And for that, we're not using any technique. It's just a simple one. We're not using any of the ways that we saw to scale applications. Okay? And that's very useful. Very easy to do it. So you see there's not much code here. Very easy to do it. Now, to understand the benefits of some of other methods, I'm just going to add here a processor. And this processor doesn't have much logic. The only thing it's going to do is put here thread sleep. So I'm going to even decrease this time. Right? So it doesn't do anything different. I'm just going to see now the rental. Okay. And we can, oops, select. Oh, yeah, thank you. Let's see, 10,000 records over there. Okay? So now I'm going to run the same example, just adding this thread sleep. So this is, again, not using any of the techniques that we saw. So what's going to happen now is for each item, it's going to read. The processor is going to sleep for 3 milliseconds. Okay? And what's going to happen now? Now it's going to take much more time to complete, right? Because Spring Batch, by default, is not smart enough to understand, okay, we're not doing anything here, but I'm just going to be here waiting for you to complete. So this process probably is going to take, I don't know, 3 milliseconds times 3,000, about, I don't know, 40 seconds to complete, because our thread now is being held on the processor for each item that we read. That's going to be held. So it's completed. So you can see here, it took 45 seconds to complete now. Again, if you get here, 30 seconds out of that was because of the sleep. The other one completed in 10 seconds, so 40, a little 5 seconds overhead. So you can see that was way more costly to do it. Okay? So now we're going to see the async. Okay? So as I said, the async, they need to walk together, the processor and the writer. Nothing different here in the job. Our job is exactly the same. It's going to read exactly the same file. Same number here on the chunk, has 500 by time. And we're saying that the processor is going to be an async item processor. That's the only difference from the other. Same thread sleep here. We should put the same. I'm going to leave 5 milliseconds. So we had 3 milliseconds before. We're going to leave the 5 milliseconds. And you can see here the async processor, it's nothing special. So you're just declaring how the data that's going to come in, object type that's going to come out. And I'm going to delegate my processing to this processor here, which is this guy that we saw here. And with the writer, it's not different. So we're just delegate the async item writer is going to just delegate the job to the writer. So we saw that with the simple profile, it took 45 seconds to complete this task. How long do you think that's going to take now? Guess? 10 seconds? Oh, good one. 10 seconds. All right. So instead of 45 seconds, it took 10 seconds to complete the task. So if you can see that 10 seconds is very similar to what the first example was without the thread sleep. Because that's pretty much what's doing. The thread is not there waiting for the processing to complete. Said, oh, I need to do some processing here. I'm going to send that to another thread, and when that completes, and I'm going to send a future to my writer. And the writer, once the data is available, the writer just gets this result. So it's not going to be there waiting for it to complete. So that performs much better. Okay. All right. Next one, let's see the multithreading. You can see nothing different here from the multithreading. Is exactly the same thing as the other jobs. As we saw during the deck, here we are defining the pool size. So here saying 4 threads, same chunk. The processor is comment, so it's not going to use the processor right now. Multi-threaded, and let's run. Three seconds. Right? So now, before we were getting each chunk, this was the same thread was being used for each chunk of data, but now we split each chunk of data across 4 different processes. And that, let's see, ideally that would be about 2.5 seconds with some overhead, 3.5 seconds it took to process the same file. If we run this example with the thread sleep, we're going to see that it doesn't perform that much better than the example with the simple. I have some numbers I'm going to share later. Let me see how we were timed. All right. Okay. I'm going to show one example now using the remote chunking. I think that's going to be more interesting now. So before, I think I didn't show that. That's my fault. So we were, all our jobs, we're using a job builder, and there was to build the jobs. And now with the manager, we have this remote chunking manager step builder, remote chunking. But for the job, well, the job builder is the same. For the step, remote chunking step builder. Besides that, things are is not so different. And here is where, say, output channel, input channel. Here, okay. So that's how it's going to communicate with the MQ. Reader is the same reader, same writer, and here you have those flows to show how to communicate with the MQ. Okay, so that's using Spring integration for that. So we have the outbound flow, the requests, so where the manager is going to send the requests, and we have the responses coming in the inbound flow. And for the worker, we have here the remote chunking worker builder, processor, writer, and we have the same thing, input channel and output channel. In this case, this processor is going to be printing the record that it's reading. And for the flows, we have exactly the opposite, right? So it reads on different ones. So let me start MQ here. Okay, so MQ is running. And what I'm going to do, I'm going to start 4 of these workers. So this, if you can, let's, oops. It's not here. Okay, so that's pretty much what it's doing, is just getting this jar. So as I asked before, we're using one jar for both, and I'm using just a different Spring profile. Okay? I don't know how familiar you are with Spring profiles, but just to show, so here you have this profile worker. So when I start the application, passing the profile worker, it's going to look at this. This is a match. So it's going to initialize all the beans in this class. Okay? But for example, here we have the simple profile. So Spring Boot will look at this as, oh, that's not the same profile. It's not gonna get those beans. So for the worker, you have the worker profile, and for the manager, you have the manager profile. Okay? So that's how they are differentiated. So only one of them is going to be initialized. Right. So I'm just going to initialize this guy. So, okay. So this is a worker. I'm going to see it work. And what I'm going to do is I'm going to initialize 4 workers. 1, 2, 3, 4. 4. And how many records we have here? Records. Oh, because I'm dropping. Oh, I should have shown this before. All the jobs, they have this listener here. They were using a batch job listener. I should have shown this before. And what it does, it's getting the total number of records from this table, dropping the table and recreating. That's okay. But that runs before job. So before the job runs, this is executed. Okay. I should have shown this before. Right. So rental. Oh, that's the wrong one again. All right. 10,000 records here. Okay, and then I'm going to start one manager. Oops. Okay, and let's see, cat manager. You see, that's the same jar. Okay. Oh, cat worker is the same jar that we're using. The only difference is the profile, is really the profile. So you can see now the workers, they were initialized, but they are not doing anything. They're just listening on the port, but they are not doing anything. Okay? They were initialized. So now we're going to start the manager. And the manager is going to start consuming the data, this 10,000 records. And you can see now it's sending to the workers. Each chunk is being sent to different workers. Okay. And it completed, here in this case, took 11 seconds. Okay. You can see that there wasn't too much difference, but once you start getting much more data and you can split across that in multiple containers, right? That can be a big benefit, especially, again, when your bottleneck is your processor. So if you have a very heavy process, that's where we would see more benefits using this technique. So that's very easy to create different multiple workers. You can see that just a few lines of records, we could do that. Let me go back here to IntelliJ. Let's show something. Sure. Yeah. So the question is when the work completes a job, if it signals back to the manager. Yes, because the manager sends a chunk like of data, right? So the manager in this case is reading all the data and sending to the workers, like in this case 500 at a time. And the workers are going to get this 500 and they're going to reply back with all this data to the manager. Once it completes, the manager will understand that all the data was completed and okay, I'm good, all the data was, it's going to do some validation, the number of records or something. And perfect, and then the worker, probably here we can see that workers send, each worker received multiple times the data because it was 10,000 records and we were sending in chunks of 500. So probably we should, see, we have, here was 600 and then, I don't know, jump to 800 here later, right? So each worker in this case, as it completes, the manager can read more data and send back to the workers. In the same case, if one worker goes down, the manager will understand that and send this data back to another person to complete, another worker to complete. You have a question? Well, all right. For this case, for the remote chunking, I'm using a RabbitMQ. Okay, and RabbitMQ. So here we have a worker. I have the Docker here. The Docker is running a RabbitMQ, and we have these integration flows, which are part of the Spring integration. So I'm seeing. Maybe I show the application properties, right? So I have Spring Batch, the RabbitMQ running on localhost, guest, and this port. Okay, and this information is what the worker and the manager they see. So they're going to connect to this because Spring boot automatically will create the connection to the MQ, and there are two durable queues on MQ. So the request and the response. Let me see if I. Localhost and view channels or queues. Okay, so here we have the two durable queues, request and response. Okay, so again, the worker reads the data, pushes the data on the request queue. The workers read from the request queue, process, and reply on the response queue. Okay. You can do that in different ways. I see people using REST to do that as well. I don't know. I think MQ seems more reliable. Sure. Yeah. If you can put the async processor with remote chunking. So the question is if you can do the async processor with the chunking. You can mix and match those. Okay. You can do different things. You have the multi-threaded. You can say multi-threaded and async processor. That's fine. You can mix and match. Yeah. Cool, good question. And you know what? We can do that just to see why we discuss. We can do that. So let me do one thing here. All right, so he was asking how we're going to ensure that only one manager is going to have this. That's a good question, and I did not try that. But from what I read, Spring Batch will ensure that only one manager can run at a time. Okay? I should have done this test. And the other is that 100,000 records here. So we can run the same task. So the workers are here. So let me, don't think, oh, it's another jar now. So let me, I just recreated the jar pointing to the 100K library. So just make sure it started, find 100K. Okay, so just gonna start the 4 nodes, right? And the 4 nodes started, and we're gonna run the manager here. So now we're running a file that has 100K. Okay? And why that runs we can discuss. So you were saying that the manager will be a bottleneck now, and that's absolutely right. Okay? Because for the remote chunking, the bottleneck is the processing. Okay? So you're not concerned about the reader. Okay? So in this case, the partitioning would work better. Okay? Because when you do partitioning, the data is local to the workers. Okay, so that's another technique. It's very similar. The code would be almost the same. Okay, it's pretty similar. I don't have it here, but I can share with you later. So in this case, the workers would read the data and do everything. So and then depending on the partition, right, that you choose. But the workers, the data would be local to them, and they would have access to the job repository. If it dynamically scales, so the remote worker, so the question was if the remote worker is going to scale automatically. So no, automatically it wouldn't. So you saw in this case here, I started 4 workers. Okay? But what you can do, you can I don't know, deploy this on Kubernetes and put a limit on CPU or something and to create a new container for you, right? So once the second one is initialized, it would start to receive data. The manager would see that's available and would start to push data to it as well. Can you see what? Oh. Oh, it's completed already. In 1 minute 47. Let's see how we are with time. 30, 50. All right, so let's do one thing. I'm gonna run it again. And then it started running. And let's add a new one here. See? So that was initialized later and starts to consume messages from the MQ. Right? So you can easily scale like that as well. All right, so one last thing I want to show. do this. Oops. There are different things that are going to impact the performance, okay, of your application. So the chunk size is important. The technique they're using is important. And a question that I receive very often is, what is the right number of the chunk size? And there is no magic number, there is no rule that you can apply, oh, that's how we're going to calculate my ideal chunk size. So you need to try with your application what works best. For those who doesn't know, the thing with the chunk size is the following. If you have 100,000 records, like the example that we ran now, and you have your chunk size 1, it means that you're going to read 1, process 1, write 1, persist to the database. Okay? And then you're going to do that 100,000 times. Okay? So you're going to the database 100,000 times to do that. As you make your chunk smaller, you're going less to the database to commit the transaction. So if you have your, I don't know, 10,000, so you're going to be now you're going to go 10 times to the database to do that. Performs much better. Okay, that's good. What's the problem with that? If one of your items fail, you have 10,000 records, number 9999 fail, Spring Batch will roll back the transaction. And if you have wrote your job for this type of failures to skip the failure, right, and to ignore this case, Spring Batch will then roll back the transaction and run again, one by one sequentially to persist, to find out exactly which one failed and ignore. So then your chunk of 10,000, you're going to go like, now you're going 10,000 times to the database for this chunk of data. Okay? So you need to find the right balance between the chunk size and for your use case and performance. So here I did a benchmark, and I don't know if I can call this a benchmark. So I run like 5 times each job here on this computer. Everything's locally. Even with the remote chunk, you can see that I'm running Docker, so everything is locally. And I run different jobs. So the simple step and different chunk size. So chunk size 500, 1,000, and 5,000. And the TS for them is with the thread sleep of 5 seconds. Just to show the difference. So the simple step, you see that it didn't change that much, the performance. Well, here about like 12 seconds with a chunk size of 500, 10 seconds with 1,000, 11 seconds with 500. So it's not much, but 10% of difference in performance is significant, right? With the thread sleep, it didn't do any difference on them. Here we have the async with thread sleep. Here with the multi-threading using 4 cores and using 4 threads and using 8 threads, and the remote chunking process. So I did this, and I did the same for 100,000 records. You see the simple one with 100,000 records was like 7 minutes to complete the task. With the async took 1 minute and 40 seconds to complete the same task. Right? So that's what I wanted to show you. All the code is here on this repository, Rodrigo Graciano Cloud Batch. So you have everything there. You even have a script if you want to run this on Kubernetes, on Docker. You have some scripts here, some shell files here as well. Questions? So the question is if you can combine the remote thread, the remote worker with the thread. Let me think. I believe yes, you can. I think there's no problem with doing that. We can test. I don't have time to test that. We can test that after the presentation, but I don't think there's any problem, any limitation doing it. So the question is if it's required to use a Spring integration for that. No. It's just made easy for me to write the code for that. It's not required. In this, I chose to use MQ to do the communication, but you could be connect to MQ using whatever you want. Okay. Yeah. No, it's not. It's not. It's not a requirement. For this use case, I need a way to communicate with MQ, and I chose Spring integration. Okay? That's it. I just need to have a durable method so the worker and the manager can work with the remote chunking. Spring integration was my decision, and MQ as well, because I could have used different things. I could have used, I don't know, JMS or other things, but it's my personal decision. So you can use MQ, you can use, as I said, I saw people using REST for that, which I think it's strange. You can use, if I'm not mistaken, you can use JMS, you can use Kafka, you can use different things to do this. Sorry? So the question is if you can use the Microsoft Service Pass queue. I don't know. I can check later and get back to you. I honestly don't know. Sure. Yeah. Oh, for the async, you can configure. Otherwise, Spring will calculate a number for you. But if I'm not mistaken, you can mix with the multi-threading as well to do that. But let me. I'm gonna get. Good question. And you had a question? Sure, go ahead. Mm-hmm. Yeah. It is the work. Let me do one thing here, because I saw this behavior change, and after the talk we can run an example with that, because I saw this behavior change. When you are adding the fault tolerance, I saw this behavior before ignoring it and committing 999, and I saw it roll back in different versions and then go one by one. Okay, so I didn't run for this Spring 5 to see what it's doing, what's the behavior, but we can run this. Question? No? All right, thank you.